In this problem, we have a student running towards, at 3.5 meters per second, a rope. He hangs on the rope and he swings up and then swings back down. So we want to know how high will the student swing. So if we say this is our h is equal to 0, how high up does the student swing? So this is a problem that can be solved with conservation of energy. So the initial potential energy plus the initial kinetic energy is the final potential plus the final kinetic. Energy is conserved before and afterwards. So and potential energy comes in several forms, but one is gravitational potential. Kinetic is going to have the same formula, 1/2 mv squared. So let's ask yourself, does it have potential energy before he swings up? Well, if we're saying this is the 0 and he starts at the ground level, no, mg, its initial height is going to be 0. How about kinetic energy? Is he moving? Yeah, he's moving initially at 3.5 meters per second. Final potential energy. Yeah, it swings up to some height at its highest point. So, mg, we're going to try to find what that final height is. Final height. And kinetic energy, we got to think about this one. Picture someone running, swinging up, getting to the highest point, and then swinging back down. At its highest point, it stops moving. Its speed is 0 momentarily, just at that highest point. So if we look at the beginning, there's no potential. At the end, there's no kinetic. Now we just have to solve for h final. You might notice that you don't even need to know the mass in this problem, because if we divide both sides by m, our mass cancels. So we can just solve for this final height. How high will the student swing? H final is equal to, put your g on the other side, so we have 1/2 and g is 9.8, so we have 1/2. Find that 0.625 meters. And we're done. Next question I want to go over is, we've got a string attached. Now this length right here is 1.2 meters. 1.2 meters from here all the way down to the end of the pendulum. So the pendulum is pulled up until it makes a 25-degree angle to the vertical. Okay. What is the speed of the pendulum bob when it passes through its equilibrium position? This is its equilibrium position. Hint, to determine the vertical drop of the pendulum bob first. So it gives you a little hint. Okay. So let's just think about what's happening right here. You're holding it right here with your hand, and all of a sudden you let it go, and it swings. So initially, what type of energy did it have? If you're holding it there, I mean, initially it had gravitational potential energy. And as soon as you let it go, that gets transferred into kinetic energy. It starts moving. So let me say that here is where my height is equal to 0. We could have made that spot down here as well. But that's where my height is equal to 0. Alright. we want to know, the hint tells us determine the vertical drop of the pendulum first. Okay, what is this height? We can find that height, which is the center of one ball to the center of the other ball, by using this side and this angle. So let me try to draw a triangle here, and it might be easier to see. We have 1.2 meters. Then the length of that string, this string right here, that doesn't change. I mean, this is still 1.2 meters. Instead of being over here, it's just over here now. Now I can use right angle triangles to help find that height. So this angle is 25 degrees. If I want to find what this height is, let me use a different color. It'll help visualize this. This is 1.2. This is some side that we don't know, but we can find because we can use the hypotenuse and this angle to find this side. Okay, so to find the green part, what we can do is we can say 1.2, 25 degrees. I can find what this side is, I'll call it y, by using cos angle. It's adjacent over hypotenuse. Cos of 25 degrees. My adjacent side is y. My hypotenuse is 1.2. I can find what y. So we find y to be 1.09. Alright. Now, this might take a little visualization. This red part is equal to blue minus green. So I'll write that up here. Red is equal to blue minus green. So red is the height. This is the vertical drop of the pendulum. So if I want to know what that length is, my blue side is 1.2 meters. My green one we just found was 1.09 meters. So the difference between those two is 0.11 meters. Okay, that's the vertical drop. That's how much, if I set this as my h is equal to 0, if I say this is my ground level, that's the initial height that this one started with, or this bob right here. That's the initial height that it started with. So when we do energy conservation, just like the previous problem, and we say our final potential energy, if it's on the ground, it's not, this is where our h is equal to 0. If we say that's 0, when we do our initial energy, mgh initial, that initial height is going to be 0.11 meters. Now, at the beginning, we're holding it here. It doesn't have any speed. Its velocity is 0. So its kinetic energy is 0. At the end, well, now it's going to be moving. So it will have a kinetic energy. So from here, all we have to do is just find what the velocity is, what v is, what the speed is. So again, look at this problem. We can erase, divide both sides by m. We don't have to worry about the mass at all. We can solve for v. We have g Your initial height we just found was 0.11 is equal to 1/2 V final. G is 9.8, so we can rearrange and say V is equal to, I'll write V squared is equal to 9.8, 0.11 divided by 1/2. And if I want to find V, I got to take the square root of that. We find it to be 1.5 meters per second.